Good evening, one and all. In today's session, it is actually somewhat the last topic of core Java concepts, that is exception handling. And this exception handling, it is actually used to build the reliable software. It is supported by different programming languages like C++, Java, Python. Each of these languages, and maybe some other languages also, they support this exception handling mechanism. By writing certain code, you can implement this exception handler in your program. And why it is used to build reliable software is because consider an example that I've actually already explained about errors and exceptions in the previous lecture. Okay, previous session. There I explained about runtime error and compile time error. So exceptions are nothing but they are the runtime errors. Means the errors that you get when your program is executing due to the interaction of the user with your program. For example, if your program is to divide two numbers a and b, so it is a upon b, a is the numerator, b is the denominator, then which value of denominator is not acceptable? If the value is 0, you cannot divide by a 0 number. So such cases will not be detected at compile time because you just have two variables. A, you'll accept the input from the user. You have a variable B, you'll accept the input from the user. If the numbers are like 6 and 12, you won't get any error. Suppose it is 14 upon 7, you won't get any error. But only if the value of B, since it is A upon B, if B is equal to 0, that time only you'll get an error. And when the 0 comes, when it does not come, it depends on the user. Only if the user enters 0, you'll get an error. So depending on how the user interacts, when your program is running, you'll get the error. Is it clear what is runtime error? That is called as exception. Is it clear?
Yes.
Yes.
Another example can be, suppose the user is given a choice to enter the index of the array. So suppose the array size is 8, then the index will be from 0 to 7. Okay, maximum, the index, that is the value of I suppose, is equal to 7. Suppose the user wants to choose the index 10. Then in such cases, you'll get an error because there is no index 10 existing in your array. If the user enters the index 2, then it is possible because array size is 8, index is up to 7, 2 is included in that range. That time, no error. But if the number is greater than 7, then you get an error. So this is another example of user interaction which is causing exceptions in your program. There can be many such examples we will see in the presentation now. So if you want to handle such exceptions, you need to use exception handling. What will happen if you don't handle it? If you don't handle such cases, these are the input cases or the test cases that will run on your program using your program. If you don't handle such cases of input, then automatically the program will end or it will terminate. You won't get any output and it will just close. The running of your program, that will stop. So this is not a good way of exiting, right? We should always suppose at maximum what we can do, we can display some message that the input is invalid. Please enter the input again. So it will make the software reliable. It will not just abruptly shut down or close or something like that. So that is why we can use the exception handling. Okay. Is it clear till here, whatever I said?
Yes.
Okay. So we have certain topics in this major topic. So first of all, what are errors? Errors, as I said, they can be either compile time errors or runtime errors. So basically, an error is something which may produce an incorrect output or some abrupt behavior which is not accepted and it is not expected. I am audible, right?
Yes.
Yes.
Yes. Okay. Yeah. So um, and such incorrect output or some abnormal behavior, you can say, it may terminate the execution of your normal program suddenly, or even the system may crash. Usually system crashes in C++, they can happen in case you're accessing the illegal memory locations using pointers. Using pointer, you can access the address of something. If that address is something which you should not access, then you get certain exceptions. That is also one case in C++. But in Java, we don't have pointers, so that case is not possible in Java. So it is therefore important to detect and manage properly all the possible error conditions for reliable software and to uh, if you want to avoid the abnormal behavior of your program. So compile time errors, another example can be for compile time errors, that is before, means when you compile your program, at that point it will give you the error messages, not while running. Before you can run your program itself, it will give you the message. Now compiling and running is what? First of all, you compile your program. If there are any errors, it will display the error message. If there are no errors, then only it will run. If there are errors, then first of all you have to eliminate the errors. When there are zero errors, then your program will start running. So compile time errors are the errors that you get after compiling and before running the program. I hope this is clear. So compile time errors are usually the syntax errors. Like if you miss a semicolon at the end of the statement, if you miss certain curly bracket, you have opened the bracket after main, but you forget to close it here. That is a problem. Then in identifiers or keywords, instead of writing if for if else, you write IFF. That means the identifier is a wrong identifier over here. It will not accept IFF. So that is another example. Then double quotes and strings, that is another example. If you use undeclared variables, directly you're printing the value of A, but you have not declared A anywhere in your program. So that is an error. Then incompatible types, if you are assigning a long inside an integer or a float to a character variable, such a mismatch between data type and value of the variable, that is another example. Then use of equal to in place of double equal to. Why do we use equal to? Can anyone tell me? A single equal to, where have you seen it? Why do we use it? Can someone tell me?
Assignment operator.
Assignment.
Yes, assignment operator like a equal to 5. And where do we use double equal to?
Comparison
For
operator.
comparison.
Yes, comparisons. Okay. So sometimes when you don't write your if the condition inside your if statement, there usually we use the double equal to. If the double equal to we don't give, then it, and we give single equal to, then in some cases you get error, or some cases it acts as an assignment, which is always true. So for if loop will get executed. So we'll see that later on. But usually in if statement, there are comparisons in the condition of if. That time we use double equal to. Then and so on. Okay, these are some examples. There are many more also. Now, runtime error is what we can tackle using the exception handling, because compile time errors the compiler itself will handle, but the runtime errors we don't have anyone. We ourselves have to include that logic in our program, and once that logic is there in our program to handle the exception, that time the exception handling mechanism will work for us. So runtime errors after compiling is completed. That means you don't have any errors. Then only program runs. And when the program is running, you may be in the testing phase. Suppose you're testing your program, you're checking for various inputs. Okay. If you miss an input, then later on in the production phase of your software and all, it will give you problems. Then again, you have to rectify and all. So first of all, you have to test your software or program completely, and then only you can share it with others. Otherwise, if they find the errors, and then that doesn't look good. Actually, it proves that you're inefficient. So that should not be the case. So most common runtime errors have been listed here. Divide by zero error. Then accessing an element which is outside the bound of your array. That's what I said. Index 10 is not there for an array of size 8, right? Then attempting to use negative size for an array. Like if you write a of 5, maybe the array can store 5 elements maximum. If you are writing a of minus 5, then that is again an error. It's not possible to have negative size, right? Then trying to store a value of incompatible type. That is your type conversion between one data type to another data type. If they are not compatible, if they cannot be used together, then that time you get an error. Then invalid string to a number. If you're converting a string to an integer, you have certain methods in Java to do that, like integer dot parse int, and then you have to give the string in the parenthesis to convert a string to an integer. If the string, like for example, if your string is equal to within quotes 123, then you can convert this to an integer. How? Because 123 within the double quotes, you can easily, if you make it as an integer, the value will be within an integer, it will be 123. But suppose your string is ABC, and ABC you want to convert to an integer. That is not possible. So your input should be valid such that it can get converted to an integer. So that also gives an error or an exception if it is not possible, like in case of ABC. Then other examples are there. So an exception is a condition caused by the running or the runtime of the program. and Java interpreter encounters an error, it creates an exception object and throws it. So what does this mean is whenever an exception occurs, suppose you're dividing by 0, then that is an unsafe state, you can say. And to come out of that or to deal with it in a better way, to handle the exception, the Java interpreter creates an object of an exception class. Now, exception is the name of a class also. Okay, it is a predefined class. The name of that class is what? Exception. Like how you have your thread class, runnable interface, that exception is a class. And the object of this class is created, like exception obj equal to new exception. Object is created. And when the exception is occurring in your program, that object will be thrown from that point to some other point. For example, if the exception is occurring in this particular curly brackets over here, then from here, the object of exception class will be created over here automatically. Or you can also specify that object will be created, and that object will be thrown from this position to some other position in your program, wherein you have written the logic to handle the exception. What I said, at the point at which the exception is occurring, at that point object will be created of the exception class automatically. Once that object is created, that object will be thrown somewhere in your program. It will be thrown to that some location in your program, and there the exception handling logic you have implemented. So if the object is thrown from here to here, if the object is thrown from here to here, then over here the logic is there to handle the exception. Okay, so this is how you come to know that which logic has to be implemented to handle which exception. Wherever the object is thrown means wherever the object will be caught, you'll throw the object from where? You'll throw the object from the point of exception, and it will be caught at the location at which the handling logic is written. Wherever the logic to handle the program is there, that logic will catch the object which is thrown. So like how you throw a ball from point A to point B, from point A you're throwing the object, at point B you're catching the object. That same thing will happen over here. This is only done so that your exception handling logic is separated from your actual program logic. You can write the exception logic at that point only where the exception is working, where the exception is occurring. There also you can write, but it is always preferred to keep all the logic to handle the exceptions, all that exception logic, to keep it separate from your actual program. That is why we are throwing an object from that point to this point. Is it clear?
Yes, sir.
Okay, so the programmer or the developer may want to continue the execution of the same program even after the exception has occurred. This is possible only if you handle that exception. If you don't handle it, as I told you, program will just end, it will terminate abruptly, abnormally. So this task of handling such runtime errors called as exceptions is called as exception handling. So reliability, and these are some steps. Like first of all, you have to detect the exception. Then you have to throw, that means you have to pass that information that yes, exception has occurred. You have to give that information. Then the logic will receive that information, and then the logic will be implemented. So these are some steps. Okay, if you want, you can remember it. It is a part of theory actually. So first is detect, then inform, then catch the information, and then implement the corrective action or logic. So it is also called as hit, throw, catch, handle. Then exception handling is uh, consists of two segments. One is detecting and throwing, and one is catching and performing. So detection and throw will happen at the top or maybe at one point, and catching and performing the logic for handling, that will be at another point. As I said, from this particular point, your detection and throwing of the object will happen, and at some other point, the catching of that object or the information and implementing the corrective logic, that will happen. So first two steps in one section, next two steps in another section. The programmer always has to be on lookout of such exceptions, some common already defined exceptions. Now, the exception may be specific to your program, or it may be common to the entire world. For example, dividing by 0, it is common to the entire world. It is not that only in your program it is not allowed. It is not allowed for every program. Am I right? In every program it is not allowed, right?
Yes.
Yes. So this, why the user has to write the logic on his own for such exceptions, which are existing for everyone. That is why a common platform or common logic is provided by the developer to handle this divide by 0 exception. You don't have to tackle it. You have to just throw the object from one place to another place. You don't have to write the corrective action as such. Means you can write it if you want, but it will be handled. Means the compiler, the interpreter knows about such an exception. It already knows that divide by zero may happen in the program, and the compiler or interpreter should be ready to handle it. So other than divide by zero, it is actually called as an arithmetic exception. When you divide by zero, it is a type of arithmetic exception. And this, whatever I've written here, arithmetic exception, this thing is also the name of a class. Like as I said, exception is the name of a class. Arithmetic exception is again the name of a class. And then you can see the next one is array index out of bound exception. This is again the name of a class. So all these exception types are nothing but the names of some classes in which the logic is there to handle it. And you have to simply create the object of that class and throw it from there to here. And you can add your own logic also to it. Okay, so something is predefined, you can use that, or you can define your own logic also. So array index out of bound is for the if you're trying to access an index which is not in the array. Then array store exception, again something which is common for everyone. That is, your programming is trying to store a wrong data type inside the array. Means the array can store only integers, but you're trying to store a string value in that. Okay, so this is array store exception. It is different from array index out of bound exception. Out of bound exception is for the index, and array store exception is for the data type of the array. Then file not found exception. If you're trying to access a file, like file handling concept in Java, if you're accessing some file, some resource which does not exist, then again it is an exception. Because unless your program runs, it will not understand whether the file is present or absent. Once the program runs, if the file is found, no exception. If the file is not found, exception. Then there is something called as null pointer object, a null pointer exception, sorry. So this is by referencing a null object. Null object means it does not have proper definition or something like that associated with that. So that time you have this null pointer exception that we'll see in the program. Then number format exception. It is when you're converting strings to numbers or numbers to strings. So especially you have a problem only when you convert a string to a number. Why I say so? Because if you have a string ABC, is it possible to convert ABC into an integer? Yes, no?
No.
No.
No. So here you have a problem. Okay, I'll write problem over here. But if you want to convert a string, which is within quotes 123 to an integer, here no problem, this will work. Okay, so string to integer, there may be some problem. But suppose you have an integer which you want to convert to a string. For example, integer may be 123. If you convert 123 into a string, it will become within quotes 123. Right? You can have any integer, -10, +5, +1000. All these can easily get converted into a string. So integer to string, you don't have any exception. But string to integer, you have an exception if the string contains characters. If the string contains numbers within quotes, then no problem. But if the string has such characters within itself, then you have a problem. Did you understand why we have exception when string to integer and there is no exception for integer to string? Is it clear?
Yes, sir.
Yes.
Yes. Okay, then other thing is stack overflow exception. So this is usually when the space or the memory of your stack gets overflowed, or means if it overflows or if it is full. Okay, so these are some standard exceptions which are common for most of the programs and all. So they have already been implemented up to an extent and you can use it directly. You can also define your own custom exception. Means suppose a problem is there in your program. Suppose, for example, in your password section, you're not allowing the user to enter special characters like asterisk, hashtag, @ These characters are not allowed in the password. But still, if the user is entering the special character, that time you can display the error message exception. But maybe in someone else's program, that special character is allowed. That time, no need of handling exception. So some exceptions may be specific to your program, your implementation. That time also you can define exception, and for which are common, you have already some logic for that. Is it clear till now?
Yes.
Yes.
Okay. Basic concepts of exception handling. Now, as I said, first of all, detect, then throw, then catch, and perform the corrective action. So there is something called as try block, in which you will detect the error. Okay, try block is used to detect the error, and inside the try block or from the try block, you will throw something. So try is the first thing that you have in your exception handling logic. try block. Like how you have your if statement, you have your if, and inside your if within curly brackets you'll write some logic. Similarly, you'll write try, and within the try, within the curly brackets you'll write some logic to detect the error. Maybe you can say that if b is equal to 0, then throw the object. In case of divide by 0, if b is the denominator, you can say if b is equal to 0, throw. That's something you can write inside the try block, and then it will be caught wherever you've written the corrective logic. Then catch block is used to catch the object which is thrown by the try block. Try will throw the object, catch will catch the object, and inside the catch, once it catches the object, it will perform certain operation. Maybe using that object you can display some information. Now throwing an object means what? With that object, the information related to the exception also will be thrown. Inside that object, if you access that object which you throw, you're throwing some object. With that object, using that object, you can access some information which will help you to debug and all that. So that is also possible. So both these things, it is the exception handling logic. People also call it the try block as the exception object creator, and the catch block as the exception handler. Okay, both have to be used together. So try is another keyword, and catch is also another keyword. And catch block should always follow the try block. Means what? You cannot have catch, and after catch, if you are writing try, that will give you an error. You cannot have this. Always try and then the catch. And without the try, you cannot have the catch. Means you're saying that I will write only the catch block. No. If you're writing only the catch block, who will throw the object? Try block only will throw the object. So try block is compulsory. If you're saying I'll write only try block, who will catch the object? So catch block is also compulsory. So both have to be there together, and one after the other in this order only: try, then catch. And also the try block, after the try, you can have multiple catch blocks. For example, you may say that you have try, and after try, you can have catch. After the catch, you can have another catch. After this catch, you can have another catch, and so on. So this is similar to if, else if, else if, else if, and finally else. Am I right?
Yes.
Yes.
Yes. Okay. So it is similar to that. You can remember that also. You can have, so another thing that you come to know is a single try can be followed by multiple catch, and at least one catch. Means you can have one catch, two catch blocks, three catch blocks, and so on. Now, why do we have multiple catch blocks? Is because inside your try, it is not compulsory that only one type of exception will occur. Means what? Inside your try, maybe divide by 0 exception is occurring, and inside the try, same try, inside that array index out of bound exception is also occurring. There may be multiple exceptions that are happening inside the same try block. So to handle all these exceptions, you can have multiple catch blocks. One catch block can be to handle the divide by 0 error. The next catch block can be used to handle the array out of bound index exception. The next catch block can be used for some other exception. So you can have multiple catch blocks. But there's another thing. What if you want to create a single catch block for all the exceptions? That is also possible. Okay, for all the exceptions, you can have a single catch block. Or if you want to handle everything specifically, exception for each exception you want to handle separately, that is also possible. That is why you can have at least one or multiple catch blocks. Is it clear why multiple catch blocks?
Yes, sir.
Yes. Yes.
Yes. Okay. So this is one example program. This is also for divide by 0 only. So you have a class called as divide by 0 exception handling. This can be anything, okay? Here it is not necessary the class name should be this only. It can be anything. Till now how we were giving class names, it can be anything. Inside that you have a particular function which is named as quotient, and it will return the quotient. Whenever you do a divided by b, you get quotient. Whenever you do a percentage or mod b, that time you get remainder. So this is returning the quotient. That's why the name of the function is quotient. And you're passing the parameters numerator and denominator, that is a and b. Means I'm just calling it a and b. Here it is nothing but numerator upon denominator. And in your main function, first of all, what you'll have to do, if you want to access this class, inside the class you have the logic, right, for calculating quotient. So first of all, you have to access the class. How you'll access the class? By creating an object of the class. That means the class name obj equal to new class name. Okay. And when you're creating the object, the constructor also will be called automatically. And to the constructor also you can pass the numerator denominator, or maybe you can say obj dot quotient, means obj dot method name, and then also you can pass the parameters. Means either through constructor or through the normal functions you can initialize the a and b, that is numerator and denominator. So I'm using a normal function called as quotient over here, in which I'm creating the uh, I'm passing the parameters. And one more thing, here since it is static, this quotient method is static. So without creating object also I can access this method. That is why I have not created object over here. But suppose quotient was not static, it was a normal method, static keyword was absent, then I had to create an object and then obj.quotient. But here, since it is static method, we know that it is shared for all the objects of the class. So no need to create class name. You can directly call the method. You can say quotient and pass the parameters. And what value is returned by the quotient? A upon B. Whatever the quotient is, that is returned, which I'm storing in the result variable. And then I can print the value of result. Is this program clear? What is happening here?
Yes, sir.
Yes. Okay. So here is some sample execution cases. 100 upon 7 is possible. Then you have 100 upon 0. Now here it is a exception. Now till now we have not used the try, catch and all that which I was talking about. Okay. So as you can see, there is no try and catch. So it will directly give some error messages and something like that, and it will terminate. It is not quite readable, as you can see here. Okay, this is not quite understandable. It is saying something divide by 0, no exception handling and all, means something is missing and all that it is happening. Another case where it can fail is what? Where the data type that you're passing is wrong. You should only pass integers. Suppose you're passing string, for example, 100 upon hello. That's what you want to do. So this in case is again a error in which the data type is not matching. So these are some errors that can happen. So to handle this, this is the program. Okay, that was without the exception handling logic. This program is with the handling logic. So here what I've done, everything is same. Only thing, the main I have written the try and catch within the main block, within the main method. So what I've done, I am first of all accepting the number. Okay, this is actually this program is to accept the data from a dialog box. Means there is graphical user interface in this program, but you can implement it without that also, no problem. So what is actually happening is I will accept the two numbers, and then if I'll write in my try block, what I'll write, if denominator is equal to 0, then throw what that I'll show you in the program, and then it will be caught by the catch block, which is over here. And inside the catch block, I will display some messages. Maybe I can also tell the user re-enter the denominator, and then this will continue. Like it will be handled all the times. Suppose there's no error, everything is working perfectly, then just like your normal program, you'll get the output. Okay, try catch is for what? Only for handling exceptions. So if you include try catch, there is no exception, then normal program it will become. It will be a normal program, normal output. Okay. So that's what I was showing you, graphical user interface. See what is happening. Enter the first number 50, enter second number 0. Now it will give you such exception. It will display what? It will first of all display the package inside which the arithmetic exception class has been defined. I told you that all these exceptions are nothing but the names of the classes in which the handling logic is there, a part of it. So it is in the java.lang package that it will display, and the name of the exception that is same as the name of the class, and it will give you some brief description like divide by 0. And then even you can write something like num2 cannot be 0. This you can also write. Okay, you can say please enter the correct number, this is not possible. Some things like that also you can write. You can add your own things also. But the first line, java.lang arithmetic exception, that is by the interpreter that you have got. So then maybe he will tell re-enter the second number. And that time, if you enter 25, for example, you'll get the result. Is the second case is what? Normal program. But the first case was having an exception in it. Then you can have multiple Just a minute. Audible? Is it audible? Hello?
Yes.
Yes.
Yeah, yeah, it just got disconnected, so I was wondering. Yeah. So I was saying if you want to handle multiple exceptions using a single catch block, that time what you will do, now all the exceptions are inside the exception class, and each exception can be specific. So if you create an object of the exception class, there is another class called as exception. If you create an object of exception class, you can handle all the exceptions. If you create an object of arithmetic exception class, then you can handle only that exception. If you create an exception of array index out of bound class, then only that exception using that class you can handle. But if you create an object of exception class, you can handle all the exceptions. And in such a case, single catch block is required. Okay, so another thing, remember one thing, that in inheritance, whenever we created classes, or even if without inheritance, we used to write class A, and then we used to define something, then class B, and then we used to define something. Now class A and class B, there's nothing known as inheritance till now over here. Okay, but still there is some inheritance implemented by the um, interpreter and compiler, by the Java programming environment. Still there is some inheritance, though I have not mentioned it. That is because each class that you create in your program is by default automatically a child of a class called as object class. Okay, there is a class called as object. Okay, this class is predefined by Java. There is a class called as what? Object. And this object class is the parent for all the classes that you create in your program. So even if you don't mention any inheritance in your program, each class is by default a child of the object class. And then you can have your own inheritance logic also, like B class B extends class A. Now that also you can have your own customized inheritance, but by default, all the classes are children of the object class. Is this clear?
Yes.
And you don't have to mention that. Means you don't have to write class A extends object. That is not needed. It is handled by the environment. And from this object class, it is the parent of all the classes in Java. Okay, not only your own classes, of all the classes. So class A is a child of object class. Class B is a child of object class. Similarly, there are other classes which are developed already. Like we have the thread class and all that. They are also children of object class. Similarly, like how in multi-threading you had thread class as one of the parent classes, from which you used to derive your own class. Thread class was a class. That thread is a parent of object class. Thread class is a child of object class. Similarly, in exception handling also you have a particular class called as throwable. So this throwable class is a child of object class. And the child of throwable is what? Exception is a child of throwable. Error is a child of throwable. And I was talking about exception class, right? I was saying that exception class is the parent of all the exceptions, as you can see here. There is something called as IO exception, which is a child of this exception class. There is a runtime exception, which is a child of this exception class. So what you have is object, after that throwable, and then you have exceptions as something else, and errors are something else. Exception means runtime error. Error means your compile time error. That is what is the meaning of exception and error. Error is what? Your other errors. And exceptions are the runtime errors. So you have object, throwable, exceptions, and errors. And within exceptions, you have runtime exception. That is just to separate some things. Exception may be runtime, and there's another type of runtime exception called as IO exception. Means it is just more specific they're trying to be by showing this diagram. So object, throwable, exception, error. And inside exception class, you have two other classes: runtime exception, IO exception. Then inside runtime exception, you have further things. And inside runtime exception, the other exceptions like arithmetic exception, array index out of bound. Till now, whatever we saw, all those come under runtime exception, which comes under exception, which comes under throwable, which comes under object. So this hierarchy is there for every Java program. Is it clear?
Yes.
What about others?
Yes, sir.
Okay.
Yes. 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 Yes.
Okay. So Just a minute. Okay, so let us see some programs now. So first of all, and even if you want to know more about errors, till now we were handling runtime errors called as exceptions. Now what are the errors? The errors may be syntax error, it may be logical error, runtime error. Okay, runtime error is nothing but exception, which we have seen till now. Other errors can be your errors which are not exceptions. Which are the errors which are not the exceptions? Those errors can be logical error. Means there is problem in the logic of your program. For example, if you want to find out the prime numbers in your program, means you want to detect whether the number is prime number or not, but whatever program you wrote is for Armstrong number. So the logic is wrong, right? Means you won't get any error output, any error message. There'll be no error, but the logic that you have implemented is wrong. So it is called as logical error. Is it clear what is the meaning of logical error?
Yes, sir.
Okay, then there can be syntax error. Syntax error means what? The semicolons are missing, or you're using a variable without declaring it, and so on. Okay, so these are some program examples for that. You can go through it later. So our main focus is for exception handling, runtime exceptions, runtime errors, which in which we use try catch. So let us first see a program without try catch and then with try catch. So this is again divide by zero error program. So if I run it without exception handling, where b is already zero, I have initialized b as zero, that is denominator is already zero. So okay, I need to run this file. See here, you can see some abrupt termination of your program. Why I say abrupt? Because see carefully here, c is equal to a divided by b. So whenever you perform a divided by b, at that point after it comes to know that b is zero, means a is this one 6000, b is zero. Okay, but whenever you do a divide by zero, only that time it will give you the exception error. If you simply say a is 6000, b is zero, that's fine. But only if you do a divided by b, you get the exception, and at that point everything will stop. So your program will not move further. That is why I'm saying, because once it stops here, I cannot see the println statement. I cannot see the result is. I cannot see this because it has stopped over here itself at line number 8. That means abruptly it has stopped. Suddenly it has stopped. It has not gone further. That is what has happened here. So that is the drawback of exception, that suddenly it will stop in between if the exception occurs. So to handle this case, whatever code I've written, a divided by b, I will write that same code, no change, that same code, only put it in a try block. Okay, there's no change in the logic of your program. Only thing, you have to put that logic inside your try block. So that same thing, c is equal to a divided by b, and I'm printing the value of c. That is inside my try block. Now, if an exception occurs inside the try block, now an object will be created automatically. I told you that object gets created automatically, or you can create the object. For the standard exceptions like divide by zero, array index, array store exception, all those standard exceptions they are called, for them the object creation can be automatic. But if you want to implement your own logic, then that time you have to create the object and throw it. But for now, since these are the standard exceptions, object creation is automatically, it has happened in the background, and that object will be thrown. Where it will be thrown, to which block, can you tell me?
Catch block.
Catch block. And how I can, and where inside catch will it be caught? Means catch block also. Why it is called catch block? Because it will catch that object. Where it will be caught? Over here. You have to, for try block, there is no brackets over here, but here you have the brackets, parenthesis. And whatever object gets thrown, that will get stored in this E object. Means what? Whenever we create an object, how do we do it? Let us see that. Whenever I create an object, suppose the name of the class is test. I write test, T is the name of the object, suppose, then I write new test and brackets semicolon. So actually what is the actual meaning of this? We say T is the object of test class. Okay, but actually the correct thing is that the object is the right hand side and we are referring to that object using this identifier called as T. what I said, the right hand side is the thing which is the object, and we are referring to that object by the identifier T, and the name of the data type of this identifier is the class name test. Okay, so right hand side is actually called as is actually the object, and this T is nothing but it is a entity, an identifier which has some data type, which is nothing but the name of the class, because class is user defined data type. If you have int over here, then T is a member of the, it is the having the data type integer. If it is test, it is having the data type test, which is the name of the class. So T is a reference using which, or a entity, an identifier, it is a reference to refer to your object which is at the right hand side. Okay, so object creation, whenever happens, this much is sufficient, new test brackets. But if you want to access the object, like if you want to write obj dot method name, obj dot data member, if you want to do such things, it is not always possible to write this dot calling the method, something like this. It will not work like this. Okay, that is why we use that reference T. So using T, you can access this object, and then it is possible to say T dot the name of the function. Okay, so whenever you create an object, just for creating an object, the right hand side is sufficient. So what happens internally, only the object of the exception class is created. At the background it is happening, object of the exception class is created. So if I want to create an object of the class exception, what changes I have to make in this? Can anyone tell me? Here, what should I write? In place of new test, what change should I make so that this thing becomes an object of the exception class? Any idea? Am I audible? If you don't know
Yes.
the answer, okay, no problem. Okay, so it's actually basic thing. What I'm saying, if I create an object of exception class, how I'll create it? If I want to create in the normal way, test t equal to new obj, new test. So like that, if I'm creating an object of exception class, what I'll write? Anyone can tell me?
New exception.
Yeah, I will write new exception, but till now, how we have done, what I'll write? I will write
Class
what?
exception.
Exception obj equal to what?
New
New
exception.
exception.
New exception, right? Till now, we have been doing it like this. But now we have to only do the right hand side, means background, in the background it will happen, only the right hand side will be done. Okay, so instead of test, your answer should have been that. Here I have to simply write exception. Okay, so that is why I'm saying that, means I first showed you this one so that it becomes easy for you to know that what should be over here, right? So you know that if I'm creating an object for the exception class, if I am doing it, only this much is okay, it will work. Now if I want to refer to this object, if I want to refer to this object, I will I need to have the left hand side. Do you agree with me? If I want to access the methods, variables of this object, I need to have the left hand side. Is it correct?
Yes.
Yes. So this left hand side will be there in the catch block, because in the catch block, I have to access this object and some information and all that. So in the try block, I will throw this part. This part will be thrown. The object will be thrown. This is nothing but the object. This will be thrown. And in the catch block, it will be caught inside obj. So that is what I'm doing here. See what I'm doing here. Here I'm writing inside the catch. What I'm writing, exception E. Instead of E, you can write obj also. Okay, so exception obj will hold what? Using this exception obj is an object of exception class. So whenever you throw that object which you created, whenever you throw this, it will be caught inside obj. So it is nothing but this is the left hand side. Do you agree with me? Whatever I've written inside the catch parenthesis, this is the left hand side, right?
Yes.
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 Yes, and from the try, I'm going to throw the right hand side. Means here I can also write throw new exception. Okay, so this right hand side will get caught inside this obj. Using this obj, I can refer to that exception. But this thing which I've written, throw new exception, this will happen automatically in the background. So I'm not writing. And whatever is thrown, which happens automatically, will come inside obj. And using obj, I can do whatever I want. I can give the messages and all that. So inside obj, here you can see obj, I'm doing print ln obj, means I'm going to print the exception object. Okay, so let us see what output we get. But for now, is it clear how we are working with this try catch for the standard exceptions which already exist? Is it clear?
Yes.
Okay,
Yes.
so now let us run this program, and b is already 0. I'm hard coding, I'm initializing directly. So we'll run this. So see here, you're getting the exception in a much decent way. If you didn't use this, you are getting some red lines and all over here, and it was not quite readable. But now what it will display is, whenever you print obj, you print the object. Okay, you're printing the object itself, because that object is stored in obj variable, means it is nothing but the object only actually. So using obj, you're going to print something. When you print obj, this is the line, this one, this whole thing. What it is saying, java.lang.arithmetic exception, and the exception is divide by 0 exception. And these above line and this below line is what you have written. As you can see here, you have written that we failed to divide reason, then the object is getting printed, and then you're printing end of the program. And this end of the program is what? It is after the catch block. This is only the catch block. After the catch block also you can have statements. But if we don't use try catch, then wherever exception is happening, after that, there'll be no execution. That means if you did not have try catch, this end of program would not get displayed. But since you have try catch, the program is not getting terminated suddenly. And that is why all the outputs which are expected are visible. Is it clear how it is helping us?
Yes.
Okay, so if you don't want this way, if you don't want to print the object, you can also print obj dot get message. So this get, we know that obj is an object of which class? Anyone? Obj is an object of which class?
Exception.
Yes, it is an object of exception class. So this class also has its own methods and data members and all that, which are already defined by the developer. So one of those methods is get message. So if I do get message and if I run this program, you will get a better output maybe, which is useful for the user. Okay, which the output which is useful for the user and not the developer. What you're getting only that message divide by 0. You're not getting that java.lang.arithmetic exception. You're getting only the message actual, which is useful for the user. Being a programmer, java.lang.arithmetic exception may be useful for you, but not for the persons who are using your program. So there are so many methods like this. And if you want to know the methods, what you can do, object, and you can click on dot. It will give you the list of the methods like fill in, stack trace. This method is used for debugging to trace the traversal of the program. Then you have equals method here also, hash code. Hash code is something that whenever you create objects, they go inside a particular memory space like a virtual box. Okay, this happens in the background. They go into a particular memory space called as virtual blocks, all those objects that you create, and they go in different such virtual blocks, and each virtual block has its own hash code. Hash code is the identity of that block, virtual block, so that you can obtain using hash code. So there are different things happening in the background under the hood, which you can get to know by such things like wait and all that. Okay, we'll see that in future. Till now, is this program clear how we can access the information from the object? Is it clear?
Yes, sir.
Yes.
Okay, so this was how you can implement exception handling for a simple program like divide by 0. Now this try catch is there in C++ also, and in Python it is a little different where you have try and something else instead of catch. Okay, so the logic, that is throwing object from here to there and such things, are common for the languages. Only some syntax differences are there. Okay, so that was you can see that the object was created of the exception class, and we saw in the presentation that exception is a class which is the parent of all other specific exceptions, like array index out of bound is a child of the exception class, index out of bound, null pointer, arithmetic exception, all of them are the children of the exception class. So here we created an object of the parent, the uh, class which is the parent of all the other exception classes, the general parent. So that is why one catch block we have. Using this catch block, we can handle all the exceptions which come under the exception class. It may be divide by zero exception, array index, all that. But if you want to handle only array index, that time you have to create an object of the which class? Any idea? If you want to handle only the array index out of bound exception, is it better to create an object of the exception class, or can you be more specific?
Runtime exception class.
Yeah, you can do runtime exception, but within runtime exception, you have that array index out of bound, right? So you can simply create an object of the array index out of bound exception, because this class is
Okay.
responsible for the dividing by zero error. Okay, so if you want to be the most specific, you can create an object of this array index. You can also create an object of runtime exception class and all, but the most specific one would be that. That also let us try. Now what we have done, we have created an object of the most general class, exception class. If I write here, arithmetic exception, and now if I run my program, you'll get the same thing. So I'm running it, same output you'll get. And I'm printing the object here. That is why this lang dot thing is coming. If you want, you can print object dot get message. And now if I run, you'll only get the divide by zero, this much part, along with the we failed to divide and all that. So you're getting the same output, but you're creating an object of a more specific class because you only want to handle divide by zero. If you wanted to handle, suppose, 10 types of exceptions, that time it would be a good idea to create an object of the general exception class. Am I right?
Yes.
Yes. So we'll stop here for today. Any doubts you can ask me? Anything you want to know?
So we can have multiple try and catch blocks, right? Like try block, then catch block, then another try block, then catch
Yes,
block.
yes. Yes, absolutely. Just like how you can have if else, then another if else. Similarly, try catch, you can have it. And let me tell you one more thing. Yeah, you can put your attendance. And let me tell you one more thing. Just hold on. Uh, I wanted to tell you. Huh. So if you go to see inside the try catch, there are some compulsory blocks that get executed and some which are optional. For example, the try block will always be executed. Whatever code you write inside your try block, it is always executed. And if the exception occurs, only then the catch block will be executed. Suppose there's no exception, then catch block will never be executed. So try block will always be executed. Catch block depends on if there is an exception or not. But in if else, how it was? If the condition is true, execute if block. If the condition is false, execute else block. But here, whether the exception occurs or whether the exception does not occur, try block will always get executed, and the catch block depends on whether exception is happening or not. Any other doubts you want to ask me, you can ask now. If no doubts, you can leave the meeting. Thank you.
Thank you, sir.
Welcome.
Thank you.
Welcome.
Thank you.
Welcome.
Thank you.
Welcome. Welcome.